OK， 线上同学听得到吗 ？OK， 好。All right, so any questions before we start? Any questions before we start? So, some of you asked questions about the schedule. So I believe TA has posted the schedule online. So that's the tentative schedule， 就是那个整学期的课的时间安排了，是暂定那个样子，中间再可能会跟着调整。So that's tentative. So just for your reference. But the exam dates are fixed, are determined. So mark those 3 dates on your calendar. 第6周、第12周跟第17周。Okay, so we have 3 exams. So that will be, those 3 dates will be fixed, and there will be no online exam. Make sure you're here. Okay, physical exam. So you have to come here, take exam in this room. All the others, the homeworks, the final projects, and everything else other than the exams, all the others can be done online. Lectures, you don't have to come, you just join online, that's fine. Just I always think physical lecture will be probably the most effective, because the only problem that for online lecture is I cannot see your eyes. 就是我没有办法看到你的眼睛啊。So why is like seeing eyes so important? Because I can tell, even with your mask on, I can tell easily that this part needs to be emphasized. So I have to repeat the explanation on which part. I can see the confusion eyes. So I can make decision and start work. Do some more, give some more examples, do some more explanations. But if you're online and you turn off your camera, even with your camera on, I still cannot tell if you are following or no. OK， 就是我看不到你的眼睛，我就不知道你到底是知道不知道，懂不懂，然后需不需要再重讲。Okay, so that's about the questions. And for final projects, we will very likely invite a industry company to join. 就是有请一个业界公司来参加，来加入。So final project will based on a RISC-V processor on FPGA. Very likely, pretty much done, determined. 就是会有个公司，他们会拿 FPGA 板子来，然后里面会烧 FPGA， 各位知道是什么吗？知道了哈，就是一个可编程的逻辑阵列，你在里面烧一颗，就是弄一颗那个 RISC-V 的处理器进去。RISC-V 是一个处理器，我们会讲到。So we talk about RISC-V, and there will be a processor, a real processor for you to play with. It's likely we're still discussing what's the possible challenge for you for the final project, and likely they will probably take something out of their processor, and you have to fix them. 就是他会把东西拿掉，然后 you have to fix it, and you have to optimize it. It's very likely in that case. So that means you have to know all the details of the processor architecture, their implementation, pros and cons, and have to know the application behaviors or characteristics and how you're going to optimize it. That means you have to be able to know to read Verilog code. And you have to be able to read and understand C code. And you have to know how they work with each other. 你写的 C 程式怎么在硬体的处理器上跑，它会产生什么样的效应。And if that's the final project, then I will provide you some materials. Because some of you with different backgrounds, you probably don't know anything about Verilog, but maybe some of the C programming, but not much. We'll give you some background, and all of these materials will be online, so you have to take some time to learn. But for most of the students with electrical engineering background or computer science background, I presume you know Verilog and then you know C code, and that's the prerequisite. 那个是在课程的那个前期要求里面，希望你们有的。那没有呢，你会来问说怎么办？说很担心啊，说怎么办呢？那我会跟你讲，其实也没关系，也没有说不会就不能学，但是你的确是会多花一点时间要把它补起来。那补那个东西啊，补什么 Verilog 啊，补什么C code 啊，我相信你们补得起来的，但是花时间下去绝对补得起来。那你们都已经坐在这里，我不相信你们能力不够这回事啊，看不懂什么没有，就是决心不够而已，决心够就都补得起来，那没有什么，那不是很难的一件事情。Okay, so I'm not worrying about if you don't have any background, you don't have the Verilog background, you don't have the C code background. I'm not worried too much about it as long as you really think this is the things you want to learn. There are tons of materials online, and I'll point you to some very good ones, and you can learn by yourself. Because eventually you need to know, right? 迟早要知道。Alright, so that's about the final projects, and we will see more information maybe in March or in April. Okay, any questions? 到这边有没有问题？ So, I want to double check one thing, which is, let me pull that out. I want to double check our new plan, which is this one. So again, if you are new, because 我才刚签了一个加签哦，他就是加签这门课，就是他还找不到教室，所以代表他上礼拜都没来。So there are some new students. So if you are new, this is the new plan that we plan to do in the starting next week. So for this class, we have 2 sessions. One is a 2-hour session, maybe not 2 hours, 100 minutes on Tuesday, which is now. The other one is 50 minutes on Thursday. And it's really bad time, really bad 50 minutes, which is the last session on Thursday. And I believe that's not efficient. This 1 hour, not even 1 hour, 50 minutes, not efficient. So I propose to consolidate the lecture on Tuesday. So we will start the lecture, this one on Tuesday earlier, 10 minutes earlier. We will end the lecture 10 minutes later. And we'll skip the break. So that will give us 30 more minutes on Tuesday. And I believe that 30 more minutes on Tuesday will be more efficient than spending 50 minutes on Thursday. Because you only have 50 minutes, you have to take 10 minutes out from beginning, you have to take 10 minutes out in the end. And you only have 30 minutes, and it's not that efficient, 30 minutes. So, and if we remove Thursday's lecture, consolidating the Thursday lecture on Tuesday, then you have to come here only once. 就是只要来一次啊，对不对？那个 travel overhead, you can save one travel overhead, actually 2, come back and forth. 所以2次 and you have extra 1 hour on Thursday, and you can plan around it or plan with it. Okay. So we will, again, Thursday, I will still be here. I'll finish maybe chapter 1. And starting next week, we will do this new plan. Okay. Any objection? 有没有反对的？自爱难行，可以了啊。OK， 线上同学 OK 了啊。So we will do this starting next week. OK， 好，没问题啊。Any questions before we start? All right. So last week, we talked about some great ideas, and we talk about great ideas in architecture or digital system design, and we talk about the layers of the program below your program. So we talk about on the top, you have the application software, which is written in high level language, like Python, like C, C++, like Perl, or some other high level languages. Those are high level languages, and you have system software, which includes contain this compiler. This compiler is like a translator and optimizer to take your high level language, your C, C++, or Python, your Java, and translate them into machine code, and send this machine code to the operating system. Operating system 作业系统，像 like your Windows, your Linux, your Mac OS, and that operating system will be handling the input output management, the memory, and scheduling the task, etc. And then run on your hardware. Hardware is a processor, your memory, your I/O controller. So the high level of the programming code looks like this. On the top level, this is your C code. This is a C code of swap, 就是交换啊，就把 A 放到一个地方，然后把 B 放去 A， 然后再把 A 从那个暂存器拿过来放，然后把 A 跟 B 交换。So swap two variables. It's a function. So on the top level, looks like this. You move the V to a temporary, and then you move VK plus 1 to VK, and you move temporary back to VK plus 1. So 就交换 VK and VK plus 1. Swap these two values. So that's high level language. It's a level of abstraction closer to problem domain. Let me ask you one question. Why do you need high level language? 你为什么要 high level language? High level programming language. What's the main purpose? 在回答那个之前，我先让你看什么叫 low level language. Let me show you what's low level language. It's here. It's here. That's low level language. And that's high level language. So why do you need to write your program in Python instead of that machine language? 你为什么不直接写那个？你要写 Python? Of course, easier to understand, right? Hey, interaction. You can, even though that's a very simple answer, you can like give me some feedback so I know. Yeah, you're following. Yeah, that's because it's easier for you, for us, human, to comprehend, to understand what's going on, and to write down or to give the idea that what you want to do. And this language, when you have your idea and what you want to do described in this language, then you can use compiler to translate them into the middle level called assembly language, which is the instruction set of RISC-V, and then use assembler to generate the actual 0 and 1 machine code, 就是0101这种机器语言。So you cannot write this. This is machine code. Only machine understands. And assembly language, maybe you can understand. Like I know this is the addition, 还有一个加法，有没有 add, and it has a load. LD 是 load 吧，只要 load 进来是 load, and you have a jump. 这个 JAL, jump and link. So you have different instructions you can write. You can still manage, but still very very difficult. You'll feel that later on in the next chapter. 我下一章你就会看到那个写 assembly 多难啊，写这个组合语言多难啊。它就是告诉一个机器人怎么去打篮球这样。先往右跨一步，然后手拿起来，然后转过来，然后投起来，然后就一步一步来，like a step by step to do a very complicated operation by given very detailed operation. That step one by one step. That's assembly language. Still, you can understand, but still very hard. Still very hard for human to manage. So that's the reason why you write your thoughts, your idea at the high level language and use tools to translate it into the low level machine language. That's the main purpose. And because you're keeping your code at high level, so it will give you better productivity and portability. Productivity 叫做什么？生产力啊，就是你只要 high level， 你只要写一行 code， 你知道我3秒就写完了。你去写下面那个01，你可能要写3天，就是生产力就比较高。Productivity, portability 叫做可吸性，就是你在 A 电脑写一行，你到 B 电脑也是只要写那一行，然后它的工具会帮你直接转换成不同的指令。So let me ask you, when you write Python, can it run on your Intel processor? Your PC with Intel processor? 你写个 Python， 它可以在你的桌机上面跑吗？ Intel 上面 Can it also run on your cell phone? Very likely, right? How does that happen? Because these two processors, the ARM processor, which is the one used in your cell phone, is very, very, very super, very different from the processor in your desktop. They read different languages. 就是一个是美国人，一个是这个台湾人，讲语言都不一样，可是你要用同一行字，两个人都看得懂你想要干嘛。So how did that happen? You need to have different translator, right? I translate that one line of code to language A and to language B. So tools can help you to do that. You just need to maintain your code, that one line of code at high level. So that will give you better portability, 叫可吸性的，同一个 code 在这边也可以跑，这边也可以跑，各式各样的地方都可以跑。Okay, that's called portability. Assembly language. This is the assembly language, 叫组合语言。It's a text file. You can actually read it. 它是一个文字档，这个东西是个文字档，它存成文字，你可以看。You can read it, the text file. But this text file records the instructions. Like each of this is an instruction. Each of this is 一个指令，就是站起来，左转90度，往前走2步，然后跳起来，手伸起来，那一步一步的 ，that's called instructions. One instruction, one instruction. 像这里就是说，我把什么东西往左 shift 一点 ，shift left logic SLL. I shift something to the left. And then I add some value, and I load something here, load something there, and I store something back, like that. Those are called instructions, 指令. Okay? And different processors will have different instructions. They read different instructions. Okay? And then assembler will translate this instruction into machine language. And it's binary. It's encoded instructions and data. Okay? If you have any question, you have to stop me. Okay? I try to be super slow, but if you have any question, you have to stop me. And component of the computer, the same components for all kinds of computers, like desktop, server, embedded, they have all the same components, same types of components. Of course, different components, but same types. They all have input, output, including your user interface device, like how the computer interacts with human. That's called your interface, user interface. 就是我的机器，我的电脑怎么跟我沟通。So, what are those components? You have keyboard, you have mouse, you have touch screen, right? Those are like user interface. You have storage device. You can store data in your hard disk. You can store in your flash drive. And you have network too. You connect to different devices. So all the computers, they all have this. So touch screen is a must-have user interface for post-PC era, right? So it supersedes the keyboard and mouses. So keyboard and mouses are outdated. Now everybody use touch screen. And it has a resistive and capacitive types. So most tablets and smartphones use capacitive. Capacitive allows multiple touches simultaneously. 有电阻式的和电容式的. We don't talk too much details about the difference between the two, but today most of the touch screen they use capacitive 跟电容式的，不用管，反正压了会动，这样就对了。All right, for screen. How does the screen works or projector, let's say? So all we know there are three origin color, right? 三元是 RGB, right? Red, green, and blue. So you will have a memory in your computer to record or to give information about which pixel I want to show which color on it. 就是这里面的 pixel， 比如640×480，640×480点，每一个点我要打什么颜色 ，RGB 的那个强度各是多少？比如说每一个，比如说每一个三原色，每一个原色呢我是用，假设我有4个 level， 那我就用2个 bit 就可以用了，对不对？所以我就总共加起来6个 bit RGB。So you need to record. You need to give information to the screen or to the projector which pixel you want, which color at what intensity. Okay, so that space or that component is called frame buffer. So it records which pixel and which color and for which intensity, for what intensity for which color. Okay, and then the device or the projector will project that color to that specific position. You open the box. So I believe it's like iPad. So you have a motherboard, you have the board, and you have different components connect to it. You have the processor, and you have I/O. You have some capacitors or inductors, and you have some other like peripheral chips integrated on the same board. And if you look at the inside this board, the most important component still for today is the processor, right? This A12是一个处理器啊 ，A12 is a processor. So this processor is to do the processing, of course. So it has a data path. It basically has two parts or two types of modules. The one type is called data path. Data path is for data processing. For example, you perform addition, you perform subtraction, you perform multiplication. 加减乘除这种叫 data path. The other one is called control, 控制器. When you in your data path, you can do different things. 加减乘除、开根号什么都可以做，但是什么时候要拿什么资料来做什么动作 ？So when you want to do what and on which data, these will be controlled by the controller. So the sequence of data path, how do you interact with memories and so on and so forth. So you have different design you have to do. Even in a CPU design, later on in chapter 4, we'll talk about the inside of the CPU. You will see that there is a data path, and you will be controller for each part, different parts of the data path. Okay, and of course there's a memory, cache memory, as a small and fast SRAM memory for intermediate access to data. We'll talk about memory. So interesting thing is, this is your CPU. 1, 2, 3. On this way. So the most important factor, let's say performance factor for today, if I want to rank these three, that will be 1, 2, 3。就是我照它对效能的影响程度来说，它是倒过来的。就是 memory for today's processor is the most important performance factor. If you want to choose one and focus your optimization or design or your engineering effort, I will invest memory. How you manage the data, how you optimize the memory, how you make everything work. Data path is not much. It's pretty much everybody knows how to do that. Control, sometimes you can play some tricks. So it's still some pretty important factors there. But again, memory is the most important. So in chapter 5, we'll talk about memory hierarchy for computer system. And from my opinion, that will be the most important chapter for this class. 就是电脑系统。你今天假如说我要做跟数位系统、运算系统、高速运算、大数据计算 whatever 什么东西的计算，我要选一个 research topic， 我什么都不知道的时候，最有机会找到好的题目的，就是去看 memory， 或是去看资料管理，或是去看什么 storage 这种资料 data 量很大的地方。那些地方通常存在很多的 research topic. So if you're looking for research topic and you know nothing about CPU or computer, just start from memory. There are tons of different research and very interesting and very impactful research topics, potential research topics there. Start from there. Okay. This is just an example. This is a die photo for A16, which is the processor used in your iPhone 14. So it's TSMC 4 nanometer, 16 billion transistors. Wow. I still remember when I was an engineer in Broadcom. 我之前在那个矽谷 Broadcom 工作过，我们做的是全世界最大的晶片，仅次于 FPGA。我们做那个给 Google 或者雅虎，那个时候还有雅虎啊 ，Google、雅虎啊、百度啊，他们用的资料中心用的 switch。We were engineers making enterprise switch chip so big, really big. Like they are using the data center, high speed network switch. We were celebrating during that time. It's in 2008, 还蛮久以前了。10几年前 we were celebrating that our chip has more than 1 billion transistor. 我那时候庆祝，大肆庆祝，还发新闻稿说我们的晶片有超过1个 billion， 10亿个电晶体啊！那时候，现在已经16了，所以我们那个真的是当时。It's used for iPhone 14. It has 6 ARM cores, like not this one. Where are they? This is one. 1、2、3、4、5、6, I think. Not quite sure. Can't see it. Okay, not quite sure. So it has 6 ARM cores, 有6个 ARM 的核心 2 for performance, 4 for efficiency. Interesting. Why do you want to separate them in this way? 就是我有6颗核心，有2个是叫 performance core, 2 called performance core, 4 called efficiency core. We'll come back to talk about this. And it has 5 GPU for graphic, and it has 16 Apple neural engines for neural network processing. So these are customized neural engines. All right, let's get back here. 6 cores, 2 for performance, 4 for efficient. What does that mean? 为什么 What do you mean performance core? 什么叫效能核心 So performance cores are the core, the processor that can give you the highest peak performance. But will not give you the highest computing efficiency。什么叫效率？什么叫做什么叫 peak performance？ 什么叫做效率？就是你就想两台车的比较就好，一台车是这个一台车是那个 Hammer 好了，那个悍马车，军悍马车，一台车是 Toyota 的那个 Prius， 这两台车比较就好。So which one is the performance car? The Hammer, right? Which one is the efficiency car? The Prius. 哎，你们知道这两台车吗？我不晓得。一台是油电车，一台是军车，这样子。那哪一台？One is for military, one is for the hybrid car. Hybrid is hybrid, right? 哪一台？ Which one is the performance car? The Hammer, right? The Hammer 就是那个悍马车哦。哎，你们对车没有研究？哎，油电车知道吗？好，那我问你说 ，If I ask you which car can do the heavy job or drive the fastest, probably Hammer. Which one, if I give you the same amount of gas, can run the farthest distance? That's for Prius, the hybrid car, right? 油电车，这概念有了哈。So the processor that gives you the peak performance very likely won't give you the best efficiency. That is usually when we talk about efficiency, that is operations per watt. 你每烧1瓦的电的能量的时候，我可以做多少事？就是我给你一碗饭，你吃完之后，你可以做多少事？在你昏倒之前，可以做多少事？那个叫 efficiency。就是有人可以一次抬起很重的东西吃一碗饭，但是他抬2次就不行了，或是他走10公尺，他没力，太多 overhead 了。你瘦小的就可以吃一碗饭，我就可以跑马拉松。所以那个叫 efficiency and performance. Okay. All right. So the abstraction, the big picture is abstraction helps us deal with complexity. So high and low level details. What does that mean? 什么叫 abstraction 叫做抽象，高阶的。So that's the high level image or high level understanding of a complicated thing. 我很喜欢讲说比如说你要生日要送什么礼物，你就不知道嘛。但是呢 ，high level 告诉你，只要 Gucci 就可以，那就是去 Gucci 买东西就好，就是 high level understanding， 不要管 detail 是什么，就是管 high level 对了就好。So that can make your problem, can simplify your problem, how you handle complicated things. The other one is called instruction set architecture, ISA, called ISA. So this is the hardware-software interface. So software people doesn't know hardware architecture, but software people will know which instruction that this hardware will support, will understand. So this is called instruction set architecture. Application binary interface, that's the ISA plus system software interface. And implementation, that's the details under the interface. So different abstraction layer that will give you different level of complexity that you can handle your system. All right, the safe place for data, you have different data storage technology. For example, in volatile memory, you can have volatile memory and have non-volatile memory. 这两个差别是什么？一个叫挥发性记忆体，一个叫非挥发性记忆体。什么叫非挥发？什么叫挥发性？挥发性就是会挥发嘛，对不对 ？That means when you unplug, when you lose a power source, you lose the data. Give me an example. Which one is a volatile memory? 哪一种 memory 叫 volatile memory? 没电，东西就不见了。你告诉我一种 memory. Give me one. 有没有？你的 USB 没电，资料还在吗？在啊，所以它就不是嘛。So volatile memory, You don't know any volatile memory? DRAM is 你去光华商场，你去 Nova 不是原价屋，你不是有电脑不是要买记忆体吗？什么8G、16G 的记忆体吗？The memory, the DRAM you bought for your computer, that's called volatile memory. Okay, because when you unplug it, when you turn off the computer, the data in the memory is gone. That's called volatile memory. And your USB disk, your hard disk, those are non-volatile memory. So when you turn off the computer, when you turn off the power, the data is still there. One question, let me ask if you know. Flash memory, do you know who invented? 你知道谁发明 flash memory 的吗？ The flash memory 的技术 the key technology for the flash memory. You know who is the inventor? 你们应该都不知道，你有听过施敏那个人吗？没施敏是我们系的老师，我手的老师。So, Shi Min is a very senior professor. He's still around. You can see him. 中研院士 You can see him around here. He is the inventor for flash memory. 就是 when he was with I think it's with the IBM TJ Watson, with the IBM AT&T lab. 以前的 AT&T lab. When he was with them. When he first, this story, this is from him directly. 这是他自己讲的。他说 when he invented this technology, flash memory technology, when he first invented, he wrote very excited and wrote down the technology into a paper and give the paper to his supervisor, 给他的经理。他那时候是小职员嘛，给经理看，很厉害啊，这个。他的经理拜托他，千万不要拿出来发表，会被笑。他说他的经理不知道这个东西拿出来要干嘛用。So his manager doesn't know what to do with this technology, and he tried to convince Professor Shi Min not to publish his work because it will be a very very embarrassing thing. Like you publish some technology that nobody knows how to use them. That's like 40 years ago. 他已经几年，就是30-40年前了。那这个技术呢，其实是影响现在的电脑系统很大的一个技术。所以当时发明出来的时候，没有人知道它拿来干嘛。所以你们也有可能是发明某种东西，但是你现在不知道干嘛，说10年后就非常有用。Okay. All right, network. Everybody knows network. It's a communication, resource sharing, and can access the machine remotely. So we have different levels of network. We have the local area network, like the Ethernet you use, wide area network, wireless network, Wi-Fi. So I think pretty much everybody knows Wi-Fi today. Do you know Ethernet? 你知道 Ethernet 这东西吗？就是这个网路线，这个叫 Ethernet。就是 RJ45那个插头，你们家里网路线断掉，你自己会接那个头吗？你会接那个头吗 ？Do you know how to connect the plug, the Ethernet RJ45 plug？ 我们以前大一电机系的举手这样吗？我以前大一有门课叫做电子实验，不是应用电子实验，大一哦。你知道期中考什么吗？就分组，然后你们这一组3个人，对不对？老师就丢一个电扇给你，不会动，基本上都会动。丢一个吹风机给你，丢一台电视给你，很好玩啊。我们以前还会这样子，然后你会学怎么压那个什么 RJ45的头，然后我回家。就我家旁边卖面包那个就问说你考上大学了，你哪一所？我就说交通大学。说你们要常常爬电线杆哦。为什么要爬电线杆？ 因为不是修那个什么那个红绿灯的嘛，就是大家会误会啊，所以 I like 10, 20 years ago. About Ethernet. I still remember. 没有黑板，要不然就给你画图给你看。上次说住12社的人举手一下好不好？12社啊。So, I live in dorm 12, and I'm in 108 108请派人就是去跟108同学跟他致意一下，说有一个学长曾经也住过这里，跟他们 say hi。108是在厕所旁边。那以前的网路叫做同轴电缆 ，so the old network used the coaxial cable. Coaxial 就是同轴，就是你们现在那个第4台那个线就叫同轴电缆，就是你把它剪断，不是会同轴电缆，里面看得到。So coaxial cable. So during that time, Dome 12 used coaxial cable. That means the network on the same aisle, 同一条街的网路是用串接的 ，so they connect serially. That means if 106, 104, or 102, room 106, 104, 102, if they disconnect their coaxial cable, all the network after that will be disconnected. 以前是这样，就是你要跟我住在最后一间啊，只要前面3间只要有人把插头拔掉，我的网络就断了，我就不能用，我就要去敲他的门，就是常常会就是走廊上有人骂脏话，就是因为前面那个人，就前面的房间吧，就是要换电脑嘛，电脑要换，我要装一个新的什么东西不是吗？我要先把电脑关掉，它那个网络是接进去电脑里面。这种电脑接出来接到下一间去，所以你这台电脑假如拔掉或是关机或是插卡，后面网络全部断。你们有过这种悲惨的生活？没有嘛，现在还有冷气，那时候哪有冷气啊 ？Yeah, so that's coaxial cable, but now it's like Ethernet connect to switch. 现在都是这样子了，就是一个断就断了，谁管你啊 ？All right, technology trend. 试着解。Okay. All right, so technology trend, that's the very important thing. To be a good engineer or system designer, you have to understand the trend. 你要知道趋势，你才能做一个很好的 designer. So the trend is, if you look at the DRAM, these are years, like old time, all the way to now. DRAM capacity is increasing linearly, but under the log scale. 就是它是在它是指数成长，都知道指数成长就是乘2倍、乘2倍、乘2倍、乘2倍，这样指数成长。So in 1951, every dollar you spent, you have one, let's say, capacity or performance. But now, every dollar you spend or every cost you spend, you have this much. I don't know what's that quantity. 就是我不知道是多大。So it's increasing at the log scale, increasing significantly. So semiconductor technology brings the revolution of the computer system. Everybody knows that. So silicon, so the basic, the fundamental materials to implement this is called silicon. Silicon 叫矽，就是沙子，没什么了不起。市长说我们这边产沙嘛，你们都没有在注意新闻，要不然应该会笑。你们都不知道，拜托看看新闻好不好？看看外面的世界，世界不是只有电子学或是这个电路。你不知道我们市长说我们新竹产沙吗 ？Add materials to transform properties. So you use silicon and you mix with other materials, and you can create a new, let's say, the properties that you need to implement the system. Let me ask you, it's called semiconductor. You can use silicon to build semiconductor. 什么叫 semiconductor? 半导体，为什么要半？为什么不全导？半导就好。Why you want to do semiconductor? Why not do like fully conductor? That sounds better, right? Like totally conductor. Why semiconductor? 为什么要 semiconductor？ 你知道关键在哪里吗？人类的特性的关键。人类会进步，就是因为它可以 control things. I can make it happen. I can make it not happen. I can turn it on. I can turn it off. So, semiconductor give you a property that you as a human, you can control this wire or this device to be conductor or or insulator, pretty much insulator. 可以变导体或者变绝缘体 You can control it. So what does that sound to you? That sounds like a switch. 开关就是它要制造一个开关 switch. So what is a switch? Switch is a wire that can turn on, connected, or turn off, disconnected. And this connected or disconnected is controlled by a control signal. So using this control signal, I can make the switch on or off. Okay, that's all about semiconductor. 就是半导体就是这件事情而已，它就是做开关，然后把很多开关接在一起，就可以做你要做的事情。这神奇。Okay, learn about it. Okay. Okay, so manufacturing of IC. So yeah, TSMC is really famous these days. So what does TSMC do? TSMC is making fabrication, chip fabrication. It takes the wafer from the ingot. So everything starts from silicon. So this is silicon ingot. 这个叫做晶柱. So it looks like this. Looks like this on the right hand side. Looks like this. So you take this ingot and you slice it. You slice it, becomes wafer, 晶圆, wafer. And then you pass through 20 to 40. Nowadays, like 100 to 200, several hundreds. 这个制成的步骤现在已经几百上千了，就不是24，这个已经太久了。So pass through these hundreds of processing steps, and you have patterned wafer. That means you already have chips. You already have the circuits on top of the wafer, fabricated on top of it. And then you do tester, because you test if you have like hundreds of wafers. You test which wafer is good, which wafer is not good. And then after that, you take the good wafer, dice it, 切小块 becomes different dies. And these dies back to the package, 包装、封装、日月光他们在做的事情。And then pass to part tester, remove the fail one, and you can ship the good chip to the customer. Looks like this. Okay? And there's a keyword called yield. Yield 叫良率，就是你每做1000个晶片里面做出来以后，你有几个是好的，那个叫良率，这不是 TSMC 最擅长的。Okay, so this is the wafer for Intel Core 10. Looks like it has 300mm 12寸晶圆，506 chips, 10 nanometer technology, and each chip is like this, like 1 centimeter by 1 centimeter, 就是1公分 by 1公分大而已。All right, so for integrated circuit cost 就是你的成本 is cost per wafer divided by dies per wafer multiplied by yield， 就是你一个晶圆里面有几个晶片，乘上有几个是好的，那你所有的成本除以那个你最后是好的那几颗，那就是一颗多少，对不对？就一颗多少，一颗的成本是多少 ？Right? These are dies per wafer multiplied by yield. That means how many good die there. And if you have the cost, you divide it by the number of good die. That will be the cost of every good die. Make sense? Okay. Dies per wafer, approximately that's the area divided by die area. 就是你的 wafer 的面积除以你一颗带的面积，但要扣掉旁边一些边际效应，没有办法放斜斜的地方不能放。So the yield equals this equation. That's 1 over 1 plus defects per area multiplied by die area divided by 2. And take the square. So this equation you don't have to know. You don't have to memorize. 你不需要知道这个 equation. But you have to keep one thing in mind. First is, how does this equation come from? 为什么这 equation 长这样？怎么推导？理论推导出来的？这没有理论，这叫经验公式。这叫经验，就是 empirical equation。empirical 就是经验值，经验值公式，它没有什么理论。So the yield, but 有一些有迹可循啦，但是没有什么太深的理论。So yield is not proportion, is the inverse proportion to, that's the second thing you need to know, inverse proportion to defects per area and die per area, the die area. 这个叫什么？这个叫做你的defect 这种东西啊，就是你每单位面积会产生错误，就是你在制程中产生问题的几率的那个数量，每单位面积平均产生的数量，这个东西就跟你的制程成熟度有关系啊。你的台积电就做得很好，这个值就很小。你去什么 Global Foundry 啊，其他地方啊，什么中芯啊，它就很烂，就很高，单位面积的 defect 数目。So that's depending on how good your engineers are. You have good engineers, this defects per area will go down. The second, engineer means process engineer, semiconductor engineers in TSMC. The other one is the factor you can control called die area. The die area is how large each die is. So the larger the die, the lower the yield. Why? 你每一个 die 的面积越大 ，yield 就降低。为什么？因为你就越有可能被鸟大便打中嘛。胖的人比较容易被鸟大便打中。没有啊，因为他比较胖，然后掉下来几率比较高嘛，是不是？所以，你比较瘦的话，就是闪过了这样。所以一样的例子，一样的道理啊。你的 die area 越大，你就很有可能有 defect 掉到中间去，掉到中间整个 chip 就毁了。So the larger the die area, the higher the possibility you have a defect in there. Okay, so if you have one defect in there, it's in the critical points of your chip, then that chip fails. So you have lower yield. Making sense? 可以吗？可以啊，鸟大便理论嘛。所以这个是为什么要减肥啊 ？All right, let's look at any questions so far? 有什么问题？太快太慢 I try to be super slow. So if you feel I'm very slow, that's correct because I try to be slow. I try to let everybody catching up. But if you feel it's still too fast or a lot of things that you understand, then please come talk to me. 假如你还是觉得很快啊，跟不上啊，不知道我在讲什么那就要赶快来找我。All right, defining performance. We actually talked about this concept before. I give you 4 different airplanes. Which one has the best performance? When I'm talking about this, I give you 4 different machines, A, B, C, D. Tell me which one has the best performance. When I ask you these questions, and you should, what should you do? You should ask me, what's my performance definition, right? 我们有讲过这个嘛？上一次有没有？有没有？就是很帅，什么叫很帅？是鼻子挺呢，还是眼睛大呢？眉毛粗呢？怎么样啊？什么叫很帅？不一定啊，每个人不一样。So 你说很帅的时候，你就要说，那你的帅的定义是什么？列给我看，可以量化。So I give you 4 airplane. Airbus A380, 380, it takes the most passenger, 载最多人 777 and Concorde and Boeing 737. So fewer passenger, but Boeing 777 has the longest cruising range, 可以飞最远。Concorde, it has the highest cruising speed. Concorde 你们知道是什么？协和号，法国那个协和号，你不知道吗？超音速的飞机啊，超音速的客机。你们有这么年轻吗？没有吧？协和号我不知道，就是你一张纸拿来折纸飞机折出来那个样子，就是协和号，就是这样三角形。协和号啊 ，Concorde 啊，就是以前有一个超音速的飞机要写好，但是有一次就是一起飞就炸掉了，所以从此就不飞了。你不知道这个故事，就是那种笑话，我要赶快改版本。讲的每次要讲事情，你们都听不懂，我就很没有什么动力。Alright, so so that means different airplanes, they have different properties. So which one are you going to choose? Okay, so there's one possible way of choosing the airplane is to look at the passenger throughput， 就是 passenger 乘上它飞的里程数乘起来。那这样当做，因为这样的话可以换最多的钱嘛。Right? You can transform this into the tickets, ticket expense or ticket fees or the money that you can earn by sending these passengers. So Airbus A380 that's the highest one. Well, depends, right? This is just one possible options to evaluate which airplane you want to buy. 不是所有人都买 A380 嘛？这个飞机啊，不是所有人都买这个嘛？一定有人买这个买那个买这不一样各式各样的飞机，所以这个是因为你的考量不同。So when you're concerned, you're at different positions for different purposes, then you have different definitions for performance. It's not always the same. Everybody has different ones. Okay? Response time and throughput. Interesting concept. 一个叫做 response time, 一个叫做 throughput. So response time is how long it takes to do the task. Throughput is total work done per unit time. 好，一个叫做我多快完成这个工作，第二个是我在1分钟内才可以完成多少项工作，这两个是一样的事情吗 ？Are they the same thing？ 我完成这一个工作要1分钟，和我1分钟内可以完成几个工作，这两个在讲的事情是一样的吗？是一样的。Do you think these are the same thing? I finished this work in like 1 minute. And or the other way to describe this is I can complete one task in every minute. 就是我1分钟可以完成一个工作，和我完成这个工作要花1分钟，这两个是一样的概念。或者是 or I change the other way。好了，就原来那个好了，这可以。I use 1 minute to finish this work. The other way is I in this minute I can finish one work. Are they the same thing? 它是一样的事情吗？是一样的事情吗？ Interesting. Or let me ask you a question. So, if I can finish the task in a shorter time, then I will finish more task for a unit time period. 就是我假如可以把工作做得越快完成，我在单位时间内可以完成的工作数就会增加。Is this correct? If I can finish one job in a shorter time, then for the certain time period, I can finish more work. 这件事是对的吗？ Pretty much. Sounds good, right? 好像是对的。那我再问你一个问题啊，有2个人，一个人呢做同一件工作，做同一件工作的时候 ，A 做的比较快，所以在单位时间内 ，A 就一定可以完成更多的工作。这个对不对？就是 A 做同一件事 ，A 需要0.5秒 ，B 需要1秒。那这个时候呢，我假如让他们去做10件事 ，A 一定比较快。10件同样的事情 ，A 一定比较快。有可能吗？或者我想不出来，对不对？我再换一个例子问你好了。我要送货，从台北送到洛杉矶，一个是用飞机载，一个是用轮船，用货轮运。然后飞机载一定比较快，很短时间内完成。可是我现在假如要运一个货柜这么多东西的时候，我用飞机载还用货轮船载，谁会比较快完成？一定是飞机吗？不一定，对不对？看句子，不一定 ，right? So these two, response time and throughput, they are similar concept, but they have really subtle difference. So the processor with shorter response time will likely to have higher throughput, but not necessarily, not always. 不会是有比较短的 response time 的电脑就一定有更高的 throughput. Okay, it's not the truth. Give me one example. 你们可能讲不出这个 example. 我问你 ，CPU 跟 GPU 你知道吗？ Do you know GPU? Graphic processor, the one you plug in to play games. GPU 知道吗？什么跑 AI 要 GPU 啊，什么东西 ？NVIDIA 知道吗？有买 NVIDIA 的股票吗？没有，最近好像很惨。什么 AI 教父黄仁勋？黄仁勋是谁？你们不看那个 YouTube， 他躲在2个女生 YouTube 唱歌的后面那个。你们都没有在看 YouTube， 奇怪，那你平常到底干嘛？你不知道这回事吗？有吗？他不是躲在人家后面，鬼鬼祟祟的。然后这2个女生在唱歌啊，然后他就要他唱什么 Lady Gaga 的什么东西。没有，没看过。那你们平常在干嘛？奇怪，你们的生活跟我不太一样。Alright, so GPU 跟 CPU 啊 ，if you're talking about GPU and CPU, GPU has higher throughput, but if you give CPU and GPU the same task, CPU will run much faster. CPU finish the job way earlier than GPU, but if you give them both 10,000 tasks, 给他10000个 这边也1万，那边也1万。GPU will finish much faster, much quicker than CPU. So doesn't mean if you are comparing the system, doesn't mean that the shorter response time will give you higher throughput. Usually, but not always. Okay, so keep this in mind. They are different. 你这个搞不太清楚，你要赶快来问我。那我就叫你去看黄仁勋的那个 YouTube。How are the response time and throughput affected by replacing processor with a faster version? If you use a faster processor, of course you have shorter response time and you will have higher throughput. But adding more processor will give you the same response time, but higher throughput. Okay, so we'll focus on response time for now. 我们现在先就是我们讲到performance 的时候，我们大概就是讲 response time. So in this class, 90% of the time when we talk about performance, we talk about response time. Okay, so who cares about throughput? 我问你 ，Who cares about response time and who cares about throughput? Are they the same type of person? 就是有人会在乎我一天完成工作的总量，有人会在乎我完成一件事的时间。这两个是不太一样，你要请不一样的人，你知道吗？你要请不一样的人，就是你在乎那件事，我从接单到做完，时间要很短，这种，你要请这种人。那你要那种可以接，我一天可以接2万个单的那种，你要请那种人，不太一样的人。All right. Relative performance. All right, this should be simple. So defining the performance. Again, in this class, just in this class, we talk about response time. 我们就是讲 response time. So the performance is defined in this class only, in this class, okay? Defined as 1 over execution time. The longer the execution time, the lower the performance. And the other way around, okay? The shorter execution time, the higher the performance. Making sense? So X is n time faster than Y. Machine X, computer X is n time faster than Y. That means performance X divided by performance Y is n. Or execution time Y divided by execution time X is n. 这是定义哈. So this is how we define. A is n time faster than B. N 比 X 比 Y 快 n 倍，是这样子说的哈，是这样定义的。Example, if A use 10 seconds, B use 15. So that in that case, we can say A is 1.5 times faster than B. 可以哈，可以哈，这个简单的就是相除就知道它的比例。When we measure execution time, there are different execution time. One is called elapsed time, one is called CPU time. Elapsed time is the time you click run till the time it shows done. That's called elapsed time. CPU time is in this elapsed time, how much time is spent on CPU? 你看哦 elapsed time 就是你从你压缩开始跑到它秀说做完了，跑出来了。这个时间叫 elapsed time， 这个时间的中间一定有一部分是在 CPU 做计算，其他的不是。那 CPU 做计算那段时间叫做 CPU time。Okay, so CPU time, elapsed time is a superset. CPU time is only part of it. What are the others? The others are like memory access, I/O， 就是跟这个界面的互动啊，去记忆体拿资料都不在 CPU 里面了。Okay. All right, CPU clocking. So in digital circuits, the most widely used style is called synchronous circuit， 叫做同步电路。同步电路就是我每一个部分都是要跟着，就是大家一起运作的。So synchronous circuits, that means different parts in the same circuits, they will work at the same time. They will be triggered at the same time. So how do I know? How do each different parts of the circuits know that when to start working or when to stop? How do they know? You need a clock signal. 这个在数位电路里面或者是 VLSI 都会讲到一个叫时脉的东西，叫 clock。So all the circuits will start working at the rising edge of the clock, and then you have this clock period to finish your job. 你就有在那个时脉的一个 clock 里面，你要做完你的工作，所以这叫时脉。那一直到下一次 till the next rising edge of the clock, you start working on the next data. Okay, so you have this much time to finish your job. And every time when you see a rising edge of the clock, you start working on the new data. Okay, so clock period is duration of the clock cycle. If you have 250 picosecond, 你讲这么长啊 ，picosecond 的话，那你就是 P 是10的负12次方，250乘10的负12次方的秒啊，是0.25的 nanosecond. So this is like a unit transform. And the clock frequency is the reciprocal of that number. 就是导数啊，时间导数就是频率啊，知道啊。所以这个就是4个 gigahertz，4 gigahertz。OK， 你就算一算就知道了。Right. CPU time. Okay, so CPU time equals number of cycles on CPU 算了几个 cycles 乘上每一个 cycle 的时间。So you have 3 cycles here, multiplied by how much time for each cycle, then that's the total time. 我有3个 cycle 乘上每一个 cycle 多长时间，那我就知道3个 cycle 多少时间。That's called absolute time 啊，这就绝对时间嘛啊，这个是这样算的。So how many CPU cycles I have multiplied by how much time for each cycle, then I have my CPU time. And you can transform this clock cycle time into the reciprocal, then you have clock rate. 就是它的导数就是 rate 嘛 ，rate 就是频率嘛，对不对哈？ So the performance of the CPU can be improved by reducing the number of clock cycles, reducing or increasing the clock rate. So hardware designers must often trade off clock rate against the cycle count. Okay, we're going to talk about that. CPU time example. If I have 2 gigahertz, 10 second CPU time, if I have machine A is like this. Machine B, aim for 6 seconds to finish. But I can do faster clock cycle, but cost 1.2 times more clock cycle. 就是我把 cycle 变短之后 if I make this cycle peak clock period shorter, that means I can run faster. But sometimes when you make the cycles shorter, even though you can run faster, but you need more cycles. 有可能会这样，就是你把时脉调上去之后，你本来10000个 cycle 可以跑完的东西，变12000个 cycle 才能跑完。虽然你每一个 cycle 变短，但是你 total cycle 数变多，那是赚是赔呢？你就要算一下啊，不要就看到就做，算一下。Okay, you have to calculate because if you want, if you can make faster clock, but you will make your total number of cycles more. So are you winning or are you losing? I don't know. Make a calculation. So clock rate B is a clock cycle B, machine B divided by CPU time. So CPU time is 6 seconds. 6 seconds. 就是我要在6秒内算完。And the clock cycles for machine B is 1.2 multiplied by number of cycles from machine A because I have 1.2倍多嘛 1.2倍. All right. How about clock cycle A? Clock cycle A is CPU time of A multiplied by clock rate. 这个其实公式换过去而已啊，你就乘过去，它就变成它 number of cycles. And you have CPU time, you have 10 seconds. And multiply by clock rate. Clock rate is 2G. Gigahertz, then you have these many cycles. And you plug this number back here, that becomes 4 gigahertz. So if you want to finish, originally you run your CPU at 2 gigahertz, 10-second finish. Now you want to improve from 10 to 6， 变快一点点，变快4秒。但是你的 clock cycle、clock rate 要从2G 提到4G 才有办法。我就做一个计算，这划不划得来 ？I don't know. Is that a good trade-off? I'm not sure, but you have to do the calculation. All right. Here's also interesting thing: instruction count and the CPU. So clock cycle equals instruction count multiplied by cycles per instruction. Well, when I want to finish a program, how many cycles, how many clock cycles do I need? I will need, if I execute these many instructions, 我执行了这么多的指令，乘上每一个指令大概需要的 cycle 数，那这样就是总共的 cycle 数 right? I take the total number of instruction count, multiply by average cycles per instruction. 一个指令需要几个 cycle， 我乘上多少个 instruction 指令，那就是 total cycle 数 right? 这 OK， 这个 OK 啦啊。So CPU time 的时间就会是 total number of instruction multiplied by CPI. What is CPI? CPI 就是这个吧 ，CPI 就是 cycles per instruction， 每一个指令需要有几个 cycle， 乘上你有几个指令，那就是 total cycle 的数量。这可以啦，这个应该可以接受嘛啊。Instruction count multiplied by CPI cycles per instruction multiplied by cycle time， 每一个 cycle 多少时间？指令数乘上 CPI 就是总 cycle 数，那再乘上每一个 cycle 是2秒还是几秒，那你就知道全部的时间是多少了。That's your CPU time. Okay? So for this cycle time, you can do the reciprocal 去导数啦，就是它把弄下来，它就变成 clock rate. Okay, 它就变 clock rate. Alright, so that's your equation. If you want to make CPU time lower, then you can either increase the rate, decrease the count, decrease your cycles per instruction. 你可以这样做，减低这个或增加这个，就看你要弄哪一个。So instruction count for the program is determined by the program itself， 就是到底有多少个 instruction 这件事情，它是被你写的程式决定。你写程式是废话一堆的程式呢，还是很精简的程式呢？那这个会影响你的 instruction count。Okay, determined by your program, your instruction set architecture, and how smart your compiler is. 记得 compiler 吗？它帮你把你的 Python 转成新 code， 然后它很笨，就是转出来的 code 就很冗长，那就完蛋了。Instruction count 这样做。Average cycle per instruction determined by the CPU hardware if different instructions have different CPI. Let me ask you one thing. Look at the CPU time. If I want to make my CPU time lower, 我要让它跑快一点啊。Increasing the clock rate will be a good solution. 我就把 clock rate 变高就好了，对吗？答案是 not that simple. Why? Because if you look at this, and that, they are correlated. 它们是互相影响、互咬的。So when you make one factor higher or make one factor lower, you probably make the other one higher. Like if you make rate higher, 你把 rate 提高，你说这个提高分母提高，这个就下来嘛。If you increase the rate, but you will very likely increase the count or increase the cycles per instruction. If you make the instruction count lower, then you probably need to if you make the instruction count low, you probably will lower the rate. You have to run your process slower. Why? 你要让你的 instruction count， 你要用比较少的指令做一样的事，然后这种事情，那你每一个指令要负责的工作就会变多嘛。 就是我本来要做加减乘除4个指令，你现在要变一个，怎么做？那我就是给你一个指令，这个指令会做加减乘除，是吧？那不是一样的事情吗？你的 instruction 看到掉下来了，对不对？从4变1，本来是要做加法、减法、除法、乘法、除法，现在变成我执行一个 instruction， 这个指令呢就做加减乘除，它变成一个比较复杂的指令之后，那这个时候你就跑不快啊，因为你那个 cycle 你就要做4个动作加减乘除，你的 cycle rate 就会降。Making sense? So an example, if I want to perform arithmetic, addition, subtraction, multiplication, and division. I want to perform these 4 instructions, the 4 operations. Used to be 4 instructions, right? Addition, subtraction, multiplication, division, 4 instructions. How about if I want to make this instruction count from 4 to 1? I have to create a super instruction that will do addition, subtraction, multiplication, and division. So this super instruction, even though the instruction count is lower from 4 to 1, but this instruction becomes more complicated. So I have to lower my clock rate because my instruction already becomes very complicated. I cannot run as fast as before, so I have to slow down. Okay, so not necessarily you can win every time you optimize one factor. 就是优化其中一个东西，你通常会连带影响到其他的项目，没那么简单。OK? Make sense? Yeah. 一样，同一件事。A clock rate. So clock rate is clock frequency. Okay, any other questions? So you can start feeling about the architecture design is a trade-off. 它是个取舍后的结果。And there is no best solution. 这没有最好的解，只有合乎你要求的解，没有最好的解，最佳解。All right. So CPI examples. CPI is cycle per instruction. 每一个指令需要的 cycle 数哦。那我问你啊 is this CPI the same for every instruction? CPI 对每一个 instruction 都一样吗？你做加法和你做除法时间是一样吗？你算一题除法题和你算一题加法题时间是一样吗？不一样嘛 ，right? Depending on the complexity of the operation, you will have different cycles. Different instruction takes different number of cycles. Okay, that makes sense, right? Now let's look at this problem. Computer A cycle time is 250 picosecond. Computer B 500. So this one clock rate is faster. 这个 cycle 比较短嘛 ，rate 就比较多，比较快 ，right? Frequency is higher. CPI is 2. CPI is 1.1. The same instruction set architecture. Which one is faster and by how much? Then let's calculate the CPU time. CPU time 你就回去看那个这个了哈 ，CPU time 这是你的公式啊。这公式其实也不用背啊，你就是要理解它。它其实很简单，就3个东西乘在一起而已，其实很简单。So you have total number of instruction count multiplied by CPI A. CPI A 是2啊 ，multiplied by cycle time A. Cycle time A 是这个，乘一乘变成这样。CPU time B instruction count multiplied by CPI B。CPI B 是这个，乘上 cycle time B 这个，一乘好。然后一乘完 CPU time 再一除就知道 CPU A is faster than 谁比较快？谁比较快 ？A 比较快嘛 ？So A is faster than B by 1.2 times， 它快1.2倍。Okay. 可以哈，这个简单带进去，你理解这个，你理解前面这个公式在讲什么，你后面就是拿进去算一算这样。All right. CPI in more details. This is what we talk about. Different instructions will have different cycles. 乘法和加法就是算的时间就是不一样，虽然它都是一个 operation. Okay, usually takes more cycles to finish one multiplication than one addition. Okay, so total number of class cycles is the summation of the CPI for instruction I multiplied by number of instruction I, and you add them together. 这个东西，你假如理解，你假如可以接受不同的题目，你要花不同的时间做的话，你就会知道题目 A 有几题，题目 B 有几题，题目 C 有几题，然后题目 A 需要算完的时间乘那个题数。B 需要算的时间乘题数 ，C 需要算的乘题数，全部加在一起就是总时间，这个就在算这件事情。So you have different CPIs for different instructions. You multiply this instruction 1, and then you multiply instruction 2. You accumulate this one by one, and then you have the total number of cycles. Right? This is just the concept. So the CPI, average CPI will be the total number of cycles divided by the total number of instruction count. 你这个所有的cycle 数除以所有 instruction count 数，这个其实是一个平均值而已啊，平均值就是你算加法和算减法和算除法生，你平均算完一题的时间 ，OK， 你把它平均掉了。And if you plug this one in, then you have this summation. Okay. All right, but here you can look at this in this way. CPI sub I multiplied by instruction count I divided by total number of instruction count. 这个东西是什么？这个东西是你某个 instruction 发生的几率、发生的频率吧，应该这么说。This is the relative frequency for instruction I in your program. 就是在我的 program 里面，乘法会发生20%的次数，加法发生40%的次数，那个叫 relative frequency。OK， 乘法和加法发生的次数不一样嘛，对不对？好，那我再问你一题哦。那你写这个题目，写这一份试卷的时候，乘法占20%，加法占40%。换一个试卷给你，这个比例还成立吗？不一定 ，right？ 所以这个比那这个比例，假如我跟你说啊，你就用这样去算，你就可以推出来整个考卷算完的时间。然后我换一个考卷给你，有没有可能80%都是乘法？有啊，有可能。所以这个数字哈 ，if you look at this CPI, it's calculated by relative frequency for different instructions. So will this relative frequency be the same for different programs? If I give you different programs, will this relative frequency be the same? Or the question is, for different programs, will I do the same? Will I execute the same relative frequency of addition? 就是加法占的比例都是一样的嘛？我是不同的程式里面不一样嘛 ？Will be different, right? So if that will be different, then this CPI will be program dependent. Different program will give you different CPI, average CPI. This is the average CPI. 这个是 average CPI 啊 ，cycles per instruction, right? 哎，这边有 get 到吗？有吗？我给你5张考卷，你每一张考卷算完的时间都一样吗？不会啊，因为这张考卷加法比较多，我算比较快。那一张考卷开根号很多，所以我算超久。所以 CPI 会不一样 ，making sense？ 那你要问我
我多久可以平均解题的速度是多快？你要跟我讲是哪一张考卷啊？你开根号那一张考卷，我解题速度就很慢嘛。那你这全部都加法的，1+1=2，我就很快啊。CPI 会不一样，所以 CPI 会跟考卷哪一张考卷有关 ？Making sense? So CPI will be program dependent. Does that make sense to you? 可以啊。Questions 这个很重要，不要被唬掉。你不知道，人家就给你 CPI， 你就相信了，那你就买错东西了。All right. So if you understand that, then these examples should be easy. So you have three classes of instruction. CPI for the class is 1, 2, 3. Instruction count. Okay. I have two programs. 两个程式。Program 1 this is program 1. I have 2 instruction A, 1 instruction B, 2 instruction C. Program 2第二个 program 第二张考卷啊，加法有4题，乘法有1题，除法有1题，可以哦。那请你算平均每题解完的时间。你要算加法，1题算1分钟，乘法1题花2分钟，除法1题花3分钟。请你去算那一张考卷，你每解完1题平均花多少时间？哎，这有没有很简单？这很简单 ，exactly 就在讲这件事情。Okay, so how about sequence 1？ 考卷1号 ，total number of 有5个题目，有2个加法题，1个乘法题，2个除法题，乘完我总共花10分钟，除以5，每一题解完是2分钟。哎，对啊，我应该这样讲，很简单嘛，对不对？是不是？这样讲完你就懂了。那另外一张考卷解完1题只有1.5分钟，平均1.5分钟解1题。对吧？哈 ，So you have 4 instruction A, so multiply by 1. 1 instruction B, multiply by 2. 1 instruction C. So total 9 cycles. 9 cycles divided by total 6 instruction, then you have 1.5 CPI, average CPI. 可以啊，这很简单嘛啊，我应该这样讲。All right, so let's look at the performance summary. 等一下，现在几点？是不是超过时间了？ Total number of a performance summary. So total CPU time equals your program, how many instructions in one program, multiplied by how many cycles for each instruction, multiplied by how much time, how many seconds for each cycle. That will be your total CPU time. 这可以吗？你的程式有几个指令？你每一个指令乘上你每一个指令花的 cycle 数有多少？再乘上你每一个 cycle 的时间是多少？那就是整个的时间嘛，整个程式跑完的时间。好 ，So different factor, different parameter will be determined by different factors, like your different algorithms, 不同的演算法 will give you different instruction count, different CPI, different programming language with different instruction count, different CPI. Different compiler give you different instruction count, CPI. Instruction set architecture will also give you different, even different cycle time. 就是错综复杂的关系啊，这个三角关系啊，解不开。你改一个，你优化一个，那边变差；你改这边变好，另外一个变差；你改这边变差，那边变好，这样就是这种问题。So that's architecture， 就是它不是一个很单纯的问题，就是三角或者是八角习题这样，就是错综复杂，像《红楼梦》这样。读过《红楼梦》吗？这《红楼梦》是什么？就读完就觉得啊，这跟计算机组织差不多的一本书，就是错综复杂，没关系。All right, power trends.
For CMOS IC technology, this is the dynamic power equation. The power estimation for dynamic power. 这里我就不讲为什么算，然后这是一个 so this is the equation for dynamic power estimation, CV squared F. C 乘上 V 平方乘上 F. So C is the capacitive load multiplied by voltage squared multiplied by frequency. I will not jump into because I need a blackboard. 我需要一个黑板才能把公式导出来，就从你们的电路学和那个电学的公式导出这个公式来。那我就不导这个，你们到时候数位电路会教啊。CV squared F. When the semiconductor technology improve, advance, 就是先进制程越来越先进的时候 ，voltage drop， 这个我先讲一下这些是什么东西。The first one, this one is called capacitive load. This one is the capacitive load when you for every clock cycle. You know, in the CMOS circuits, when you are doing the switching, then it will consume the energy. 就是当你电路从1变0或0变1做转换的时候，它才会耗的。你假如没有做转换，电流没有流动，它是不会有耗的。我们先 ignore 那个漏电流啊，假设没有漏电流 ，perfect。所以这个是你的电容每一次转换的时候，你电路里面每一次转换的时候有多少的电容值，那个电容量被 charge 充放电。So this is like total number of capacitive load for every cycle in your CPU. That when you are running for every cycle, this much of capacitive load will do the charge discharge. Voltage, that's your supply voltage. 你的电源的伏特数 ，that's supply voltage square. OK， 这边有个平方。Multiply by frequency, that's the clock frequency of your circuits. So, if you multiply the three, that will be power. Total power of your CPU. For power, I want it to be as low or as high as possible. 我要 power 越 power， 但是越大越好啊，越有 power 越 powerful， 是不是这样 ？power 叫功率，功率就是你的电脑会多烫这件事情，那越不烫越好。你有被笔电烫过、大腿烫伤过吗？Have you experienced the laptop burn on your laptop? 你有经历过这种事情吗？你们应该没有啊，年纪真的是，对吧？你大腿有被烫伤过吗？有没有？没有嘛？你们现在不会有这种问题。以前你放在那边打完做完写作业写完的那一天，一拿起来脚这边都是红的，然后隔天就脱皮。你们真是太幸福，没有这种经验。Okay, so I don't want to be powerful. Okay, I want the power to be as low as possible to make it as cool as possible. Okay, so if I want to make the power low, I need to decrease capacitive load, decrease the voltage, decrease the frequency. Okay, I want everything to go down, but it's sometimes it's not possible because if you want a frequency to go down, yeah, your voltage can go down. Capacitive can go down. For more advanced semiconductor technology, the capacitive load for each transistor will become lower. 通常啦，so for this past several generations of chips, the voltage has been decreased from 5 volt to 1 volt. The frequency has been decreased or increased. 就是没有下降，反而上升，就是 frequency 越跑越快嘛。So frequency is increased by 1,000 times. Capacitive load remains the same. You say, hey, that's not right. More advanced technology, more advanced semiconductor technology, the capacitive load for each transistor will become lower. 就是
因为东西越变越小嘛，电容值应该越来越小，每个电晶体的电容值会越来越小。为什么一样 ？Why? Capacitive load remains the same for different technology, different semiconductor technology， 没什么变，维持在那个程度。Why not changing? Why not decreasing? Doesn't make sense. Because each transistor, the capacitive load is lower. How come? 你忘记一点，你的电路比以前大得多，你的电晶体比以前多很多。So the capacitive load for each transistor, of course, it's lower, much lower. But you will put more transistors in your CPU, in your system. So the total number of capacitive load remain the same. Okay. All right. How do you reduce the power? Let's do the calculation. Let's say if you can make the capacitive load to 85 of the original one, make the voltage reduced by 15%, make the frequency reduced by 15%. Then, if you compare the power of old and new one, you will be half. 你就是把 capacitive load 减成原来的85%，然后 voltage 降15%。frequency 降15%，一点点而已啊，你就省了一半的 power， 你的脚就不会烫伤。So this will very effectively reduce the number of the power consumption in your system. That's very important because power wall will limit the total number of power that you can consume. 我问你，什么叫 power wall？ 你有没有想过，我的电脑干嘛要 low power？ 我插墙壁的电。反正电费是我爸出啊，管他的。So how do you care? Why do you care about power? Why do you care about power? 电脑就是反正大不了方便放个锅子，我冬天可以煎蛋。有人用 CPU 煎GPU 煎蛋，你有看过吗？就是 GPU 在打 game 旁边在煎蛋。Why do you care? Why do you care? The higher power, that means more expensive electric bill. Who cares? I'm not paying, right? My dad is paying, so not me. Why do I care? Why do you care? 你有什么在乎要 low power？ 反正我的那个这个打游戏的机器就可以动就好了。The problem is, what will power bring you? Power will generate 什么东西 ？Power 不是说只煎蛋的吗？所以 power 越高会有什么？会有 heat. So higher power will generate heat. And the heat will increase the temperature. And the high temperature will make your system unstable. 你就会发现你电脑热档有没有热档过吗？就是弄一弄掉，就算停住了啊，还没有要到电话停住了，怎么办？或者就 shut down 这样，怎么办？就没办法。好， so higher power generate heat will cause high temperature, and that will make your system unstable, make your semiconductor system unstable. 那你就说，装个电扇就好了嘛，拿电扇吹啊。There is a limit. 就是你们用什么？用散热片啊，上面接个风扇嘛，把东西打开啊，然后拿冷气吹它。There is a limit of the amount of heat that you can dissipate using the most common heat sink technology. 就是你们现在这种散热技术可以排热的量有个极限。So there's a limit for that unit area, how much heat you can dissipate. That has an upper limit. 它是有极限的。It's about like 1 square centimeter. It's about like 100 watts. 通常1乘1公分乘1公分的晶片这个区域，你要排掉那个排热技术的极限，差不多是100瓦。所以你那个晶片要烧超过100瓦，
它就会越来越烫，你排不掉，差不多了哈。这是一个参考数字，不是绝对，差不多是这个数字。所以你去看现在的电脑，差不多都是100瓦以下，70-80啊，超频的时候变100多呢。Okay, so how else can we improve the performance? If you cannot make your system run faster at higher clock rate, how do you improve your performance? For the unit processor performance, these are the years from 1978 to 2018. The performance is increased by 52% per year. 一年增加52%，这么慢，这个叫做10年，哎，不知道10年100倍，哎，不是哦，10年100倍，对，10年效能100倍，增加100倍。So this increasing rate, the performance increase at 100x per decade. 每10年你的效能增加100倍。So these curve last for 20 years. 这个曲线幅度维持了20年，20年差不多20年，不到了啊，差不多20年。所以大概是1万倍。这里的电脑和这里的电脑差距差不多是1万倍啊，1000倍，哎，1000倍，这个不到20年了，所以这里到这里差不多是1000倍。你看从10变到1万，1000倍。So really, really significant. But after 2002, the performance increasing rate is decreased to 23, and then to 12, and then to 3.5 per year. That's the problem. That means the computer you are going to buy next year will be only 3% faster than this year. So are you going to drop your current current computer and buy a new one next year? Probably no. 通常以前是每几个月、半年换一次电脑，或者换一次里面的东西，或1年换一次。以前这个时候，当学生的时候，现在后来就不换了，因为换了也不会比较快。Okay, that will be a problem. I will skip this. 我这2页跳掉，这个 too technical. Let's jump. Skip them. All right. So so another way of thinking about， 我还是讲一讲好了，这地方。So we talk about 100% performance increase per decade, right? 52%每年 52% per year. That will make you 100%, 100x decade. Decade 是10年的意思啊。But the problem is, for the 1985 to 1995, this is called microarchitecture efficiency. That means if you don't increase the clock rate, if you don't increase your clock rate, your architecture improvement will give you 10x performance improvement per decade. 就是你不靠比较快的时脉，你单单靠架构的改善，就即使跑在一样的那个频率啊，时脉的频率，你这个10年内，1985到1995年，它还是会给你10倍的快速度。那另外10倍哪里来？刚不是说10年100倍吗？So architecture innovation gives you 10x performance improvement per decade. But I just mentioned 100 per decade. So architecture improvement gives me 10. Where's the other 10? 10乘10才是100. Where's the other 10? Architecture gives you 10x performance improvement. Where's the other 10? Higher frequency. 就是 frequency 跑10倍快 ，architecture 再给你10倍 ，that's total 100. Okay, but after 1995, 1995年以后，各位应该还没出生，这是出生前的事情了。There's nothing from architecture. Architecture gives you nothing.
So how can you still maintain 100? I have to increase my clock rate at 100x per decade. 我10年要把我的 frequency 增加100倍，就本来跑1 megahertz， 现在要跑100 megahertz， 本来跑1 gigahertz， 现在跑100 gigahertz， 才有办法100倍，因为 architecture 没用。Okay, so that's the main problem. So that's not the way to go, because if you increase your frequency, your computers become super hot. Doesn't work. Okay, so people start coming back and think about, is there any better way to do things? So that's why this multiprocessor architecture or concept comes into place. So I try to do simpler processor, but I put more of them. 我不要做一个超级厉害的电脑，我要做普通电脑，但是我放一堆，这样的话事情就会比较有效率。记得那个睡觉的时候算微积分的故事吗？ Multiprocessor, that means you have more than one processor per chip, and it requires explicit parallel programming. You have to explicit 这个是很明确的告诉你的电脑，你的事情可以平行的去做。So you try to tell, you write the parallel program to tell your processor explicitly that your job can be performed in parallel. This job can be performed in parallel. So these processors will each one take one part of the job, start doing things in parallel. So your job can be finished more efficiently. But it's not that easy. Programming for performance is not that easy. Load balancing is not easy. Optimizing communication and synchronization is not that easy. 就是没有那么简单的哈，跟工作的管理会比较麻烦。All right, I think that's it today. 好了，讲到这边了，大家已经心神不宁了。All right, so I think I'll stop here. That's for today, and we'll see you again on Thursday. Okay, I'll finish chapter 1. All right.